Welcome, ladies and gentlemen, to sqadia.com. My name is Osama, and today we are talking about interpretation of diagnostic tests and laboratory statistics in pathology. The topic that we're going to talk about today is variation in outcome measurement results and laboratory findings. And if we take a look at the contents of this lecture, so we're going to talk about the physiologic variation, the analytic variation, and the coefficient of variation and precision. So variation is of two types. It can be physiologic variation or it can be analytic variation. Analytic variation has to do with the type of test, and it is somewhat related to the reliability of those outcome measurements as well, whereas physiologic variation has to do with the normal physiological processes that are actually occurring in the human body and how can they affect the different types of result findings in different tests, either outcome measurements or laboratory tests or whatsoever. So let's start off with the physiologic variation. So physiologic variation describes variable laboratory results unrelated to disease processes. So for example, if there is an individual or there is a person, and if we perform any laboratory finding or an outcome measurement on that person, and that person or that individual can give us different laboratory results in different time, even if the same test is performed on the same individual or person, because it depends on different type of normal physiological processes as well, and is not related to a disease. For example, if we take the blood sugar of a person, so if we take blood sugar at different times of the day, so it can be different in the same individual, and that is depending upon the physiology of that individual. That can either be because of the diurnal variation or different type of activities that he did one day but he didn't do the other day, or it can also be because of the change in his diet. For example, one day he took more of the carbohydrate type of diet and one day he took more of the protein content in his diet. So that can also change his blood glucose levels whenever we take the reading or the laboratory test. That is an example of physiologic variation. Uh, Physiologic variation can also depend on the diurnal rhythm of an individual, as we see that we have an internal clock inside of us, and every individual has that, and the different type of physiological processes that are being carried out in an individual or in the human body is dependent on the time of the day. For example, we feel the need to sleep at a certain time at night, and that depends on our daily routine, and that is our diurnal rhythm. And similarly, when we wake up, there are a few individuals who do not feel the need to have breakfast early in the morning, but there are some individuals who feel the need to have breakfast very early in the morning. So that is also dependent on their diurnal rhythm. And these physiological responses also affect the physiological, different type of physiological processes like the secretion of different type of enzymes, and those enzymes accelerate or deaccelerate different type of metabolic processes like anabolism and catabolism that is being carried out in the human body, and that can also result in different type of changes in the test values. Let's take the example of the blood glucose that we're already talking about. So for example, if an anabolic hormone, for example, is released depending on the diurnal rhythm of that individual, that anabolic hormone would actually move the glucose from the blood to the tissues where it is to be consumed. So that actually would result in a change in the blood glucose levels of an individual, even though that there was no difference in the fact that the blood glucose levels were taken at the fasting state. So when laboratory results vary systematically according to the time of the day, so that is a diurnal variation. On the other hand, day-to-day variation, which results vary from day to day. For example, if we perform the same test from at one day and then the other day, then that can be different. It also depends upon the reliability of that outcome measurement tool, which we talk specifically about in different type of researches, because whenever we are trying to establish the reliability of any type of lab test or an outcome measurement, we do this as a reliability analysis, that we perform the same measurement on the same individual under the same circumstances on different days. And if that value comes or gives us the similar type of results, then that lab test or that outcome measurement is said to be highly reliable. And lesser reliable type of lab tests and outcome measurements would have a greater day-to-day variation. One another thing, important thing is that depending on the different type of activities that the person is carrying out, like for example, we were considering the example of blood glucose. So once again, let's consider the fact that diet can have the influence on blood glucose. So one day a person had the breakfast, and that person had, for example, bread and jam and margarine and those type of things with uh, sweet tea. So that person had a lot of carbohydrates in his breakfast that day. So that person is going to have high blood sugar, obviously, but that does not necessarily mean that that person is diabetic. On the other hand, if that same person had a different breakfast in the same day, which was, for example, a high protein breakfast, for example, eggs and meat or something like that in his breakfast, that would be a low carbohydrate and high protein breakfast. So that would have a result of low blood sugar or a low blood glucose for that person under the same circumstances. Now, physiologic variation, as I already discussed, can differ from day to day and from time to time, but it can also be influenced by numerous other factors. For example, diet, as well as we already discussed in the example of a high carbohydrate or a high protein diet. Similarly, for example, if we are taking the example of blood glucose, and that is a laboratory test that is carried out, and if a person has an exercise plan, and for example he does exercise on Monday and Wednesday, and or you can say that he does exercise on alternate days. So on those days there would be a different blood glucose level because of the addition of that one specific activity. Similarly, very minute things such as posture can also have a physio effect, or it can also influence the test results. For example, if you are calculating the forced expiratory volume, or we are calculating the different type of lung capacities or different type of tests that we are carrying out in an individual, and what type of posture is that person adopting can have a significant effect on the variation of those values, and it is also supported by literature and evidence. So that is one thing that we can also consider. So even the same individual and the same circumstances, but with a very small and minute factors, such as we talked about posture, can influence those values and test results. Similarly, effects of smoking. Now, some people may smoke, and some people, an individual was used to smoke and he stopped smoking, so that can also result in a variation in his test results. Or if a person started smoking, that can also result in a difference in his test values, or a variation in his test values. There are different type of medications which will also have adverse effects, or which have also different type of effects. So a person is taking one specific type of medication, and you do not consider the fact that he's or she is taking that specific type of medicine, then that can also result in difference in the, or the variation in the test values. And similarly, other things such as alcohol, etc. So we can say that different type of factors, even the most minute ones, can affect our outcome measures. Such factors are also known as confounding factors, and these type of factors are considered whenever different type of researches are being carried out as well. And to exclude the influence of these confounding variables or confounding factors, researchers do carry out regression analysis and for these type of confounding variables to make their results or the results based on their outcome measurements as free as possible from the influence of these confounding variables which are not in consideration in their studies. Now, the other type of variation is the analytic variation. Now, it is more, you can say, statistical in nature. It is more, you can say, quantitative in nature, and it is also known as precision or reproducibility. In terms of research, we also like to call it as the reliability. For example, if we measure something at one instant and then we measure again and gives us the same type of result, then we say that this thing is, or this outcome measurement or this lab test is highly reliable. Now, analytic variation describes the variability of repeated laboratory measurements on identical specimens over a specified time span. We have one specimen, we have one individual, we have one tissue or anything of the sort, and we are performing the same measurement again and again on that same thing. That is actually variability. Now, it is there are two different types in which we can describe that, also in terms of reliability. So if there is high reliability, it means there is less variation. So if there is one person or there is one specimen and there is one individual or the doctor or the laboratory specialist who is carrying out the same test on that individual again and again, and it gives that person or that doctor the same result by performing that same procedure again and again, then it is said to be high intra-rater reliability. But sometimes these different type of diagnostic procedures need to have the reliability in such a way that if any of the individuals carry out the test, it may give the same result. Now, once again, the specimen is the same, but the person that is carrying out that test is different. But even though different people carry out the same test on the same person, the results come out to be the same or similar, then that test or that outcome measurement is said to have a greater inter-rater reliability and thus lesser variation. The measurements are often repeated at daily intervals, thus assessing the daily variability or the daily reliability, as you can say. It is quantitatively described as coefficient of variation, and coefficient of variation is the ratio of the standard deviation to the mean of the values in the series. Now, we have already discussed that what is standard deviation and what is mean. So in order to just review it, mean is actually the sum of all the values divided by the total number of values. So for example, if blood glucose level of an individual was taken at 5 different times, and one time it was given as 4 millimoles per deciliter, and one time it was 4.5, and one time it was 4.8, and so on, and it was taken 5 different times. So I would have the sum of all of those values and divide them by 5, then I would get the mean. Now, standard deviation is actually the deviation of those values, those individual values that we have taken from the mean value. If there is a greater deviation of those values from the mean, then we can say that we have a greater standard deviation. And if they are closer to the mean value, then we can say that it is having a lesser standard deviation. So An individual having a greater standard deviation would have a greater coefficient of variation. And if a person is having a smaller standard deviation, then the person is having a smaller coefficient of variation. Now, if the coefficient of variation is high, then it means this measurement, this outcome measure or this test has low reliability. And if the coefficient of variation is small, then it means that this measurement tool or this outcome measurement is highly reliable. Now, coefficient of variation and its relationship to precision. Now, precision can also be debated in terms of both validity and reliability. So, coefficient of variation is an inverse measurement of precision, and as I also already discussed, reliability. So if there is a high coefficient of variation, there is less precision, there is less reliability. And if there is a lower coefficient of variation, there is greater precision and greater reliability. So an outcome measurement tool or a laboratory test is supposed to have as low as of a coefficient of variation as possible. So tests with low coefficient of variation are very precise and reliable. For example, hemoglobin level and hematocrit level. On the other hand, the tests which have a high coefficient of variation are less precise and have low reliability. For example, most serum enzyme measurements. Now, it is desirable to attain a high degree of precision if a test is used to measure the progression of a disease or the effects of therapy. So it also needs to have a high reliability, because if it's not the case, even though if an individual's condition is not progressing either in terms of worsening or either in terms of good prognosis, if a person's condition is static but the outcome measurement tool has low precision, has low reliability and a greater coefficient of variation, then that would actually result in the finding that the person is not improving nor worsening, but the different test values that we will find, we would feel or we would anticipate that the person is having a progression in his condition either in terms of favor or in against the good prognosis. So that is not a good thing for a good test or a good outcome measurement, specifically as well as in terms of research. So here is an example, for example, successive measurements of a cancer marker in a patient with known tumor. So successive measurements of cancer marker, if they are not reliable and they are not precise and they are giving different values every time, then even though there is no progression in the condition, but the doctor or the researcher would observe that there is a difference. However, there wasn't any difference at all. So it is better to use the lab tests and outcome measurements which have an established validity and high inter-rater and intra-rater reliability to find as precise results as possible. Now, to be analytically useful, the coefficient of variation ideally should not exceed 25% of physiological variation. Now, that is an important point to be considered. So in this lecture, we talked about the variation and we also talked about the reliability, and we also talked about the physiological variation, which is dependent on the normal process in the human body, and an analytical variation, which is dependent on the quantitative analysis or the qualitative analysis. And we also talked about the coefficient of variation and its relationship to precision and reliability. I hope you learned a lot out of this lecture, and please do watch the other lectures in this series as well. And I hope you learned a lot out of it. And thank you for watching sqadia.com.